So thus far, we've talked about 4 different gas laws: Boyle's law, Charles' law, Gay-Lussac's law, and the combined gas law. And each of these laws enabled us to anticipate what would happen to a certain property of a gas if we changed its conditions, like changing pressure, volume, or temperature. Now we're going to combine all of our variables together in what is called the ideal gas law. Now, what the ideal gas law allows us to do is to relate pressure, volume, number of moles, and the temperature. So the equation for the ideal gas law is the following: PV equals nRT. Okay, so let me quickly go through each of these variables just to quickly review what each of them is. So P is my pressure. And the units for pressure in my ideal gas law have to be in atmospheres. And I'll explain why in just one second. My next variable is volume. My units for volume have to be in liters. N is my number of moles. R is what we call my ideal gas law constant. Now this will always be given to you, but the value for that is 0.0821, and here are where the units come in. Okay? My units are atmospheres times liters over moles Kelvin. Okay, so that is why my pressure has to be in atmospheres, my volume has to be in liters, number of moles is moles, and my last variable here is my temperature. And notice, based on my ideal gas law constant, temperature has to be in Kelvin. All right, so what this equation allows me to do is say, okay, if I know the volume, the number of moles, and the temperature of a gas, I can figure out its pressure. Or if I know the pressure, the number of moles, and the temperature, I can figure out the volume. All right, so let's look at a couple of examples here. Example 1 says, if I have an unknown quantity of gas at a pressure of 1.2 atmospheres and a volume of 31 liters and a temperature of 87 degrees Celsius, how many moles of gas do I have? So I'm solving for N. 1.2 is my pressure. This is my volume, 31 liters, and my temperature is 87 degrees Celsius. So let's plug and chug. So PV equals nRT. Remember, my pressure has to be in atmospheres, which it is, 1.2. My volume has to be in liters, which it is, 31. I am solving for my number of moles, that's my N. My R is my gas law constant, 0.0821. Okay. And finally, my temperature needs to be in Kelvin. And so what I need to do is I need to take 87 and I need to add to that 273 to convert into Kelvin, just like we did before. And what I get here is 360. And I'm going to make that 360 point simply because when I round this value, I want to make sure I have no decimal places, but I want all 3 of these digits to be significant. Okay, so what am I going to do? I'm going to first multiply out. So I've got 1.2 times 31, and what I get here is 37.2. So 37.2 equals my number of moles times, I'm going to take 0.0821, and I'm going to multiply by 360. And what I get here is 29.556. Now all I need to do is divide both sides by 29.556. And unrounded, I get 1.259. So my number of moles equals 1.259. Okay, let's figure out Sig Figs. 1.2 has 2 Sig Figs, 31 has 2 Sig Figs, These both have 3, but I want to round to my fewest number, Sig Figs. So this will simply round to 1.3, and my units are moles. So 1.3 moles. All right, let's look at the next practice problem. If I have 40 moles, so now I'm being given my number of moles, my N, of a gas at a pressure of 4,256 millimeters of mercury, so that is my pressure, and a volume of 12 liters. Okay, if I have that, what is the temperature in degrees Celsius? So I'm solving for T. Okay, so let's plug and chug. PV equals nRT. All right, my pressure right now is in millimeters of mercury, but remember for my ideal gas law, I need to be in atmospheres. So I'm going to take 4,256 millimeters of mercury, and I need to first convert that into atmospheres. So I'm going to get out of millimeters of mercury by putting it on bottom. I'm going to get into atmospheres. I know that 1 atmosphere is 760 millimeters of mercury, and so what I get for my atmospheres, I'm going to take 4,256, I'm going to divide by 760, and what I get is 5.6. Now keep in mind, to keep with the correct number of Sig Figs, this should be 1, 2, 3, 4 Sig Figs, so 1, 2, I'm going to add 2 zeros to this, but that is my pressure in atmosphere. So now I can plug it into my equation, so 5.600. I know my volume is 12 liters. I, in this problem, know my number of moles, it's 4.0 moles. My R is my gas law constant, 0.0821. And then I'm going to solve for my temperature. Okay, so I'm going to take 5.6 and I'm going to multiply it by 12. And what I get is 67.2. Okay. That equals, I'm going to take 4.0 and multiply it by 0.0821. And what I get is 0.3284. Okay, and I'm going to multiply that by my temperature. Now I need to divide both sides by 0.3284. Okay, so I'm going to take 67.2 and divide by 0.3284. And what I get from my temperature is 204.6. Now keep in mind, you might be tempted to just box this off and be done, but remember the temperature in your ideal gas law is in Kelvin. But notice the question is asking for it in degrees Celsius. So to get into degrees Celsius, remember your temperature in Kelvin equals your temperature in Celsius plus 273. So if I'm already in Kelvin, then to get into degrees Celsius, I just need to subtract by 273. Okay, and so when I do that, what I get is negative 68.4. Remember, my last step here is subtracting, so I need to round based on decimal places. Well, 273 has no decimal places, so negative 68.4 should simply round to negative 68, and my units are degrees Celsius. All right, let's look at the next practice problem. If I have an unknown quantity of oxygen gas held at a temperature of 922 degrees Celsius in a container with a volume of 25 liters and a pressure of 560 atmospheres, how many grams of gas do I have? All right, let's write out my ideal gas law again. Keep in mind here, this is my temperature, this is my volume, this is my pressure. So right now, even though the question doesn't state it, I'm going to be solving for moles first. Once I know my number of moles, then I can figure out the grams of gas that I have. Okay, so I know my pressure is 560 atmospheres. All right, I want to be in atmospheres, I'm good with that. My volume is 25 liters, I want to be in liters, I'm good with that. I'm going to solve for N. My gas law constant is here. And then for my temperature, it has to be in Kelvin. Right now, I'm in degrees Celsius, so I need to take 922, add to that 273, and what I get is 1,195. Okay? So to solve this, I'm going to take 560 and multiply by 25. And what I get is 14,000 equals n times 0.0821 times 1,195, and I get 98.1095. Okay, and then I'm going to divide both sides by the 98. And what I get is 142.7. So my number of moles is 142. And I'm going to round here, but I'm going to keep the unrounded value in my calculator. All right? Now I'm in moles, but it asks for my value in grams. So what I now need to do is get out of moles, and I need to get into grams. Okay? Remember, this goes to way back when, but remember, to go from moles to grams, I need to use my molar mass. Well, the identity of my gas is oxygen. So I've got oxygen with a molar mass of 15.999, but there are 2 of them, so I'm going to multiply by 2, so I get 31.998. So that is the molar mass of O2, 31.998 grams for every 1 mole. So I'm going to take the value that I kept in my calculator and multiply it by 31.998, or you can simply retype it if you want to, but don't round to 142.7. Keep the whole unrounded value in there. And so what I get for my mass, unrounded, is 4,566 grams. Keep in mind, though, let's figure out sig figs. 560 has 2 sig figs, 2 sig figs, 3 sig figs, 1, 2, 3, 4 sig figs. So I need 2 sig figs, 1, 2. So this is going to be 4,600 grams. All right, last practice problem. What volume, so I'm solving for V, does 8.56 moles, that's my N, of a gas occupy at 21 degrees Celsius, that's my temperature, and this pressure? All right, so I'm solving for my volume. I'm going to use my ideal gas law again. Okay, keep in mind my pressure needs to be in atmospheres, but right now it is millimeters of mercury, so I need to convert this. I'm going to get out of millimeters of mercury and into atmospheres. Okay, I know that 1 atmosphere is 760 millimeters of mercury. So I'm going to take 750 divided by 760, and I get 0.9868. Now I'm going to keep the unrounded value in my calculator and just plug that in when I'm actually doing my calculation, so I'm not over rounding. But since I don't want to write the whole thing out here, I will just round this. Okay, my volume is what I'm solving for. That equals my number of moles, which is 8.56, times my R, which is 0.0821. And then my temperature is 21 degrees Celsius, so I need to add 273 to that to get that into Kelvin. So that's going to be 294. All right, so now what I need to do is I'm going to multiply 8.56 times 0.0821 times 294, and then I'm going to divide that by my 0.9868, but the whole value that I have in my calculator. So I'm simply going to divide by my answer. And what I get is 209.37. So my volume is 209.37. Okay. Keep in mind, let's figure out sig figs first. I've got 1, 2, 3, 4 sig figs from here. 21, I'm going to base my sig figs off of 294. So that's 1, 2, 3 sig figs there. 3 sig figs from 8.56. So I should have 3 sig figs. So this will simply round to 209. Keep in mind, my units for volume using the ideal gas law are going to be in liters. And I'm good to go.